Today we're looking at probability and odds. This is 6.7. There's a few words we're going to need to know for this section. Not hard words, just things we need to know that we probably haven't seen before. First word is outcomes. That is the possible results of an experiment. So you conduct any kind of experiment, any kind of result you get is an outcome. So when we discuss outcomes, we discuss all the possible results. Okay, an event is basically an outcome or a collection of outcomes, depending on how you define it. Some events are just one outcome, some events are a collection of outcomes. Favorable outcomes are the outcomes that match the event that you specify. Say you're flipping a coin and you say the event is, I need to flip tails, and then you flip tails. That is a favorable outcome. Okay, so an unfavorable outcome would be if you flipped heads and you were looking to flip tails. Probability, that's what we're doing today, and odds, measure of the likelihood that an event will occur. A measure of the likelihood that an event will occur. And so the formula for probability, the probability of an event happening is equal to the number of favorable outcomes divided by the number of possible outcomes. Number of favorable divided by the number of possible. Okay, so if I were to flip a coin, and I want to know the probability of flipping a tails, well, how many favorable outcomes can I have in flipping a coin? Well, if I just flip it once, so I can have one favorable outcome, and that would be tails. Let's see if we can get a pen here. Okay, so I've got one favorable outcome out of two possible outcomes. I can either flip a heads or tails, so that's two possible outcomes, one favorable. So the probability of flipping a tails when you flip a coin is 1/2. Okay. Now, experimental probability is different. That's when you conduct the experiments. If I were to flip a coin over and over again, okay, and so I look and see how many tails I actually flip. And let's say I flipped it 20 times and I had 13 tails. So that would be 13 successes divided by the number of trials. Well, the number of trials was 20. I flipped it 20 times, so that would be 13 out of 20. Okay, so that's experimental probability. You have to actually conduct the experiment to get this. Just theoretical probability, we just look at the number of favorable outcomes and divide it by the number of possible outcomes. Okay, next one. Suppose you roll a number cube. What is the probability that you roll an even number? Okay, so I'm specifying the event. I roll an even number. That's the event. Well, I need to know how many favorable outcomes I have on a number cube. Okay, so an even number, that'd be 2, 4, or 6. So I have 3 favorable over how many total outcomes? Well, I've got 1 through 6 that are total, and that equals 1/2 if I reduce it. Okay, suppose you roll a number cube. What is the probability you roll a number greater than 1? So favorable outcomes would be 2, 3, 4, 5, and 6. Well, that's 5 numbers. How many total numbers do I have on the number cube? Well, 6. So the probability is 5/6. Miniature golf course offers a free game to golfers who make a hole-in-one on the last hole. Last week, 44 out of 256 golfers made a hole-in-one on the last hole. Find the experimental probability that a golfer makes a hole-in-one on the last hole. So we're going to use this as a ratio, 44 out of 256. Okay, find the experimental probability that a golfer makes a hole-in-one on the last hole. Okay, so what I need to do is just reduce this. Okay, let's just go ahead and reduce. Let's keep reducing by 2 here. That makes it really easy. Let's see, that's 1, that's 2, that's 8. Keep going. 11 in the 64. I think that does it. So I have an experimental probability of 11/64. Okay, 44 out of 256. That I had 44 successes out of 256 trials. I make that a fraction, then I reduce it. So I get a probability, experimental probability of 11/64. You interviewed 445 randomly chosen students for the newspaper. Of the students you interviewed, 15 played sports. Find the experimental probability that the next randomly chosen student will play sports. Okay, well, favorable would be 15, playing sports, it's 15. Total would be 45. Reduce this. Okay, reduce this by 15, I get 1 out of 3. So the experimental probability is 1/3. Okay, 1 out of 3. Today you attempted 50 free throws, you made 32 of them. Use experimental probability to predict how many free throws you will make tomorrow if you attempt 75. Okay, here is 32 successes out of 50 tries, and tomorrow I want to try 75. How many should I make? Okay, based on this probability. Okay, does this make sense? So 32 out of 50, how many out of 75? Okay, so what I'll do is I'll cross multiply, which I'm not going to do here today because I don't have a calculator, but I would cross multiply. So I get 50x equals 32 times 75. Then I would divide by 50, and I've got my answer. Actually, we could probably do this pretty well. 50 multiplied by 1.5 gives us 75. So multiply 32 by 1.5, half of 32 is 16, so I add that to 32, I'm going to get 48. So I should make 48 free throws. But do you see how you would solve this if you wanted to cross multiply this to this, then this to this? Okay, then you have an equation you can solve. Now let's talk about odds. Odds in favor. That is a formula. Favorable outcomes divided by unfavorable outcomes. That differs from probability because probability, the bottom number, is total outcomes. This is unfavorable. Odds against just flips this and puts the number of unfavorable outcomes on top and the number of favorable outcomes on bottom. Okay, so if I'm flipping a coin, let's talk about flipping a coin. Odds in favor of flipping a tails. Well, favorable outcomes would be 1. Unfavorable outcomes would be 1. So we would say 1 to 1. Anytime you're dealing with odds, we like to say it like this. 1 to 1. Okay, we use the word 2. Okay, so I'm rolling a number cube. What is the odds against rolling a 1? Well, there's 5 unfavorable outcomes, 1 favorable, so we would say 5 to 1. Suppose you randomly choose a number between 1 and 20. What are the odds in favor of choosing a prime number? Odds in favor, so I need favorable divided by unfavorable. Okay, choosing a prime number. So we have 2, 3, 5, 7, 11, 13, 17, 19. So we should have 8 prime numbers between 1 and 20. So that's favorable outcome. How many numbers do I have between 1 and 20 that are unfavorable? Well, if I have 8 favorable and we have 20 numbers, that must mean I have 12 unfavorable. I can reduce this. I can divide by 4, and I get 2 over 3, which, if it's odds, we like to say 2 to 3. What are the odds against choosing a prime number? Well, if odds in favor of choosing a prime number are 2 to 3, remember the odds against just flips the formula. So we would say 3 to 2. Okay, so let's look at a little experimental probability real quick. Let's just roll this die. Let's roll it 6 times. Like to roll a 1, the probability of rolling a 1, well, it's 1 out of 6, right? So if I roll it 6 times, I should get at least 1, 1. So let's try that. Let's see if we can roll it 6 times and see what we get. There's 1, 2, so we got 1, 1, 3, 2 ones, 4, 5, and 6. So how many favorable outcomes did we get? Well, we said the event was rolling a 1, and we rolled 2 ones out of 6. So the experimental probability is 1/3. Here's the theoretical probability, 1 out of 6, but in our experiment, it was 1 out of 3. Okay, these will not ever match up. Well, they may every once in a while. But the more we roll this, if we were to roll this 100 times, this number here would get closer to this number. Okay, so the more experiments we do, the more the experimental probability will get closer and closer to the theoretical probability. So you see the difference between theoretical probability and experimental probability. Okay? So if we were to roll this 12 times, we would expect to have 2 ones out of 12 for theoretical, but it would probably differ a little bit. But it will probably be a little closer than this is to this at this time. So the more we roll this, the more this number should get closer to this number. And that's all for probability.